All right, let's go ahead and get started. So this is part two of a three-part series on an introduction to SolidEdge. In the first part, we took a look at a lot of synchronous technology. In this part, we're going to look at some of the extra features that we have within SolidEdge. So for our agenda, we are going to look at some of the basics, which is synchronous, drafting, assemblies, but we're going to see those done better. Then we're going to look at some really unique tools that are built into SolidEdge, such as being able to do conceptual mechanisms. What about plastic parts, sheet metal? How about simulation, making sure that your design is going to be robust enough? Following that up with a video on large assemblies, being able to have an entire building, an entire factory, and running it with SolidEdge. And then lastly, we're going to look at visualization. So imagine being able to take your product, take your part, and being able to take it from the computer screen to something that a consumer can really understand. That's visualization. That's what we're going to look at today. So for myself, my name is Dan Turk, and I'm an application engineer. And I've been using SolidEdge for a decent while. And as you can see with the little quote, synchronous technology, it is really awesome. And if you give SolidEdge a try, you're going to find the same thing. I work for Geometric Solutions, which is part of the Waltonen family of companies. We have Waltonen Engineering, which is in Warren, Michigan, and this is literally dozens and dozens and dozens and dozens of engineers, designers, and so on. Then we have Geometric Solutions, and what we do is we sell software solutions, software like SolidEdge and other Siemens products. Lastly, we have Independence Tooling Solutions. So not only can we design parts, but we can also manufacture them at our tooling facility. Our owner, he said it best, our ability to successfully partner with our customers comes from our experience in using the tools we sell every day. So it's not just that we're a bunch of salesmen, but rather we're users of these tools. And that's why we're able to sell them effectively and help you to be able to use them effectively. With SolidEdge, we have a nice portfolio of tools. So it's things that we might think of like mechanical design and simulation, but there's also the ability to include electronics, manufacturing, if you're using tech pubs, data management, and then everything's going to the cloud, and so is SolidEdge with cloud collaboration. So let's go ahead and get started. We're going to take a look at SolidEdge, and this is again part number 2. If you missed part 1, well, that webinar is now available on demand. So let's go ahead and get started. When we look at that little montage, you probably saw so many varieties of different products that are designed with SolidEdge. Likely one of them is similar to what you're doing. So Let's dive in. Let's take a look at the basics, but let's look at them done a little bit better with SolidEdge.
This video is an overview of SolidEdge and the design solutions it provides. Often, SolidEdge is thought of as simply a CAD tool, providing best-in-class 3D design and modeling capabilities. However, SolidEdge provides users with much more than just that, a full portfolio to meet a wide range of business needs, no matter what industry. We'll take a look at how SolidEdge not only offers rich design solutions, but simulation, manufacturing, and data management as well, all of which are scalable to meet your business needs. And if anything else is needed on top, SolidEdge has lots of add-on apps, integrations to further customize your desired solution. To begin the tour, let's take a look at what SolidEdge is best known for: design. From start to finish, designing in SolidEdge provides all the tools needed to create your custom parts and assemblies. Starting from an initial sketch, simply select the regions needed and drag them out in 3D, making visualization and creation of parts using SolidEdge's synchronous technology a breeze. Once the 3D part is formed, SolidEdge gives precision and control, driving faces and features directly using 3D dimensions. One of the most valuable aspects of SolidEdge's synchronous technology comes when unexpected design changes need to be made. The process is simple. Just visualize what needs to happen, select the associated geometry, and drive the change using SolidEdge's synchronous technology. What's even better, rebuild times and errors become a thing of the past when editing synchronous designs. If you're impressed with what you've seen so far, just wait till you see how SolidEdge handles assemblies. As we assemble our parts together, notice that much of the same capability for editing geometry that we just saw can easily be done in the assembly as well, once again allowing for faster and more precise design changes. Other great tools such as automatic placement of fastener systems such as nuts and bolts, and interference checking to ensure part fit and function round out just a few of the great capabilities that SolidEdge offers. Of course, now that our parts and assemblies are created, it's time to manufacture. SolidEdge is the king of drawings, allowing for automatic retrieval of dimensions on drawing views, automatic updates when changes are made to parts, and automatic balloon creation with parts lists, just to name a few. From direct interaction and control on parts and assemblies, to taking the guesswork and manual steps out of drawing creation, it's easy to see how SolidEdge allows you to design better.
So that was the basics, and we looked at a lot of that in part one. Just in case anyone wasn't able to join us for that webinar, I wanted to show a couple of them. But it's the basics, just done better. But what if we dive a little bit deeper into SolidEdge, into some of the enhanced features that it has? Well, let's do that by looking at conceptual mechanisms.
A common practice by engineers when designing something new is to conceptualize and lay out ideas in a 2D layout sketch. SolidEdge offers a unique method for creating a virtual assembly of components. These virtual components can come from a pre-populated list of commonly used parts and subassemblies, or new component names can be entered on the fly. The Virtual Structure Editor allows you to build a virtual list of parts and subassemblies needed for a new design. Virtual assemblies in SolidEdge may also include some real 3D models in conjunction with sketch elements. The next step is to lay out all of these virtual parts and subassemblies into a 2D layout sketch. First, a design sketch is needed for the virtual lift arm for attaching the plow to the mounting frame. SolidEdge enables you to quickly generate sketch elements like circles, lines, arcs, and curves, and automatically creates connecting relationships between these elements as they're created. The lines are drawn quickly and easily by first establishing a tangent connection, and then by making them tangent to the circle on the opposite end. Trimming can be accomplished by clicking on the elements you wish to remove, or by simply dragging over the sections to trim away. Once a sketch of the lift arm component is created, the next step is to assign the sketch elements to the virtual lift arm component. This makes sure that once you publish your virtual assembly, the component will be positioned correctly relative to the other parts in the assembly. If there are multiple instances of virtual component, the second instance can be simply placed once the sketch has been assigned to the first component. When a part is already designed, not virtual, SolidEdge enables you to create a 2D representation of that part or subassembly automatically in what is called a component sketch. This makes it very easy to add those representations into the virtual assembly and place them relative to the rest of the 2D layout. In SolidEdge, you can also add real 3D components and position them relative to the 2D sketch. Once it is in position, you can take advantage of the 2D relationships between the sketch elements and the 3D components to actually simulate the motion of the plow mechanism. Once everything is in position and you're ready to begin the real work of creating 3D models of your parts and subassemblies, you can publish the virtual assembly. This process creates new files on disk. In this case, the plow assembly has been completed by another design team, so you can just add it to replace the published plow assembly. Part of the publish process is that SolidEdge automatically pushes the assigned sketches into the SolidEdge files it created on disk. This accelerates the design process of the lift arm part. You can reuse those sketch elements to actually begin to model synchronous features in the design of the lift arm. SolidEdge's synchronous technology enables you to edit two parts at the same time by simply dragging their geometry to shorten one part and extend the other. This is something no other CAD system can do. Now that we have the components fully assembled, we can simulate the same motion with the real parts. You may want to move the lift arm assembly to a new location. If you simply move just the assembly file, it would lose its links to all of its parts and subassemblies. Using Design Manager allows you to easily select what you want to move or copy to a new location and maintain its integrity. You can also use the Design Manager to rename assemblies and part files. Using the Design Manager for this task ensures that the related assemblies and parts maintain their links. Because the lift arm assembly was moved to a new location outside of the context of the plow assembly, the file could not be found. This is easy to fix by re-establishing the link in the new folder location. Design Manager makes it easy to move, rename, copy, and fix any broken links. In summary, I think it's easy to see how SolidEdge accelerates the task of going from concept to a 3D reality. SolidEdge, design better.
So just taking a look at those conceptual mechanisms, something that would be difficult with SolidEdge, it becomes really easy. And did you notice that there is a built-in data management right into the program? Pretty nice. Let's look at the next feature, plastic part design.
SolidEdge helps designers meet the challenges of form and function in consumer product design by offering unique and powerful tools specific to plastic parts. In a top-down design approach, the trigger switch assembly is subtracted from the supporting ribs, ensuring an exact fit. Here we'll inspect the faces of the part for draft using the draft face analysis tool. We can quickly determine the pull direction and see the colors that indicate drafted and straight faces. This is a quick visual indication we have a moldable part. Another feature that is found in a large majority of plastic parts is known as a web network. These networks of ribs or web features are often used to strengthen plastic parts as well as provide support for internal components. By creating a uniform series of lines in a grid pattern, we can quickly define the center lines for the web network. By building this housing in the context of the internal components, we can ensure everything fits in the design. By physically copying specific geometry from the motor into the housing, we can create a pocket in the web network for the motor to be supported. Another common feature found in many plastic parts is a mounting boss. This feature would take several conventional modeling features and many steps to generate if it were not for the SolidEdge mounting boss command, specifically written to generate this common plastic part design geometry in a single feature. Next, we want to create a pattern of mounting boss features. The exact locations for this pattern of features have been recorded in a spreadsheet of exact X and Y distances from the parent feature. Plastic parts that are made up of two adjoining halves, like this jigsaw housing, often contain interlocking lip and groove features at the parting line. This ensures the alignment of the two halves as well as creates a moisture-resistant seal between them. Here we'll add a lip feature to the inside edge along the top of the housing. Notice that as we simply move our cursor around, we can change the location of the profile and therefore specify creating the lip above the edge. As we pan to the center of the handle area, we'll generate the same dimensional profile, yet by simply adjusting location of the profile into the part, we can quickly generate the complementary groove below the edge. The final plastic part feature we will create is a vent. Many consumer products contain electrical components inside that require airflow to keep them from overheating. This can be a very complex feature that would certainly require many conventional protrusions and cutout features to create without another SolidEdge specific command for generating them. As we return to the top level assembly, we can see how all the internal mechanisms of the jigsaw fit nicely into our ergonomic and functional plastic housing. The internal components are held in place by the internal features of the plastic housing that were created quickly and easily using process-specific features like the web network. As you can clearly see, the plastic part-specific features built into SolidEdge greatly reduce the effort in creating common geometry found throughout plastic part designs. SolidEdge, design better.
So there we took a look at the plastic part design. I think the coolest thing about this is it took longer to say what we're going to do than it actually takes to do it. Another common tool that we use a lot is sheet metal. Let's see how easily this works with SolidEdge.
We'll use SolidEdge to complete the enclosure of this heart rate monitor. SolidEdge with synchronous technology excels in sheet metal construction, allowing designers to efficiently work with surrounding components to define external product housings. In most CAD systems, the user has to modify a part independently from the overall product assembly. With SolidEdge, additional flanges can be created at the top level assembly just by selecting and dragging the plate's thickness faces. No special command necessary. Medical device manufacturers must adhere to strict government regulations, and any gaps between panels could be faulted. Using the close corner command, these gaps are eliminated. The internal circuitry produces a large amount of heat. The normal operation of this monitor relies on cooling fans. To provide clearance for airflow, we'll define rectangular cuts on both sides of the enclosure. Synchronous modeling provides several methods to intuitively match the size of these openings to the shape of the fan assembly. Now that was fast and easy. Next, we need to create a locking tab for the enclosure's lid. Here we'll select the thickness face, but opt for a partial flange to create this tab. Using one of many handy options, we'll ensure its top is flush with the top of the part. We'll lock in a precise tab location using 3D dimensions. To meet safety requirements, simple rounds will remove sharp corners. The locking tab requires a starting slot, and SolidEdge needs only a sketch line to create the slot. We'll place a hole in the slot to complete the locking tab. We get the required clearance between the top of the locking tab and the lid by pushing the tab's top face deeper into the part. Another modification made easy. The locking tab needs to be stiffened, so we'll use the gusset command. Simply specify 2 gussets and SolidEdge automatically computes the spacing between them. Since an identical tab is needed to lock the lid on the opposite side, we'll quickly fence select and mirror these features to the other side. This completes the design of the enclosure's base. Now we'll create the lid. This is where the power of SolidEdge top-down design is realized. By constructing our housing in the context of surrounding components, we can ensure all holes align and mating parts match the first time, avoiding costly rework and eliminating scrap. As before, we'll create a new flange just by dragging the lid panel's thickness face to the length we need. On the front of the lid, we need a flange that wraps to the underside of the control panel. The contour flange command not only creates a more complex flange that will fit just right, it also allows us to close the inside corners too. Notice this bend radius doesn't match the rounded corner of the control panel. No need to access the history tree, just select the bend and change the radius. Again, that was easy. Remember the fans? Proper operation will require a vent on the side of the lid. We'll create this vent by sketching a rectangle to define the vent's extent and patterning a hole using the fill option. It's as simple as that. Notice that we have an interference problem between the lid and the front of the control panel. Applying a synchronous relationship will move the vertical flange flush with the control panel's thickness face. That was an easy fix. We'll finish the enclosure by mirroring this lid half around the thickness face of the part. SolidEdge facilitates creation of manufacturing information, often with little user intervention. Watch as we automatically derive the bend table from the lid model. Finally, we'll generate a flat pattern for use in a downstream manufacturing drawing. In this case, we'll insert the bend table and add a few coordinate dimensions. Direct interaction with surrounding geometry, coupled with industry-leading sheet metal design tools and innovative modeling capabilities, makes SolidEdge the choice for companies looking for an edge over the competition. SolidEdge. Design better.
So just taking a look at the sheet metal, you can see that, as he said, SolidEdge, what does it give you? It gives you an edge. Let's take a look at simulation and optimization and see how well that works.
In this example, we'll look at simulation and optimization in SolidEdge and the benefits it brings to design engineers. SolidEdge simulation offers several different types of simulation analysis. The first that we're exploring today is beam analysis. Here, we have an engine hoist that needs to be tested to ensure that it is strong enough to hold the target weight. Using beam analysis is an efficient way for designers to quickly validate the strength of their parts, as it focuses solely on frame elements, eliminating the time and resource required to analyze complex shapes and features. When creating analyses in SolidEdge, there is a consistent and intuitive workflow followed. From defining the geometry that makes up the study, setting the appropriate loads that the part or assembly will be seeing, to setting constraints to simulate proper reactions from the elements making up the study, SolidEdge simulation allows you to create real-life scenarios on your 3D parts. For our engine hoist, we need to make sure that it can hold the 20,000 Newton force that it's rated for. Once the study is set up, running a beam analysis is very fast and efficient, as SolidEdge simulation doesn't need to worry about the exact frame geometry to solve for the reaction forces on its members. A huge benefit, especially when working with very large framework assemblies. Once solved, SolidEdge provides us with an easy-to-understand readout of the results, showing that the hoist stresses are well below the yield stress. No failures taking place here. However, if you're thinking to yourself, I've never had a design fail due to stress, how about this? A lesser known, but just as important use for SolidEdge simulation is to check to see if assemblies are overbuilt and spending more money than necessary on stock materials. For example, it's apparent that these two support frame members on the back of the assembly are overkill for the amount of stress exerted on them. Of course, making changes in SolidEdge is simple. A quick and easy edit of both of the frames to something a bit smaller, and SolidEdge is already saving us money on the less expensive stock. Once the frames have been changed out, we'll simply rerun the simulation study that's already been created. Viewing the results from the change, we can see that these tubes are much more appropriate than the previous, and we're still well under our yield stress. In addition to frame analysis, SolidEdge simulation offers several other study types. Next, let's look at how SolidEdge can use both surface bodies and solids to optimize both speed and accuracy on a more complex assembly. The leveler is made up of a threaded bolt running through an adjustment bracket used to control the balance of the engine being held. We have a requirement that the bolt can't bend more than 1 millimeter or the adjustment bracket won't work properly. To optimize the simulation analysis on the leveler, we can easily represent our sheet metal end caps as surfaces, a much more lightweight representation for the study. Mixing surfaces and general bodies is a great way to simulate sheet metal bodies along with formed parts. Now that the end caps are defined, it's time to set up the study. Setting up studies on assemblies is very similar to how we did in the beam analysis. We have to define our geometry, loads, and constraints, exactly like in the beam analysis. But this time around, unlike the beam analysis, we need to define how the parts connect together. With the beam analysis, connections are made based on how the frame cross-sections were created. But now, we're working with more than just frames, so we need to define them using any of SolidEdge's great tools. Available connection options consist of bolted, edge, and manual definition. However, one of the best time-saving options in SolidEdge simulation is the auto connection command, quickly creating all the connections automatically. Now that everything is set up, it's time to mesh and solve the study. Of course, SolidEdge gives users complete control over mesh settings for both solid and surface meshes. However, for this study, we'll just keep the default values as they've been optimized to provide accuracy and speed. Our primary interest in this study is displacement, not stress distribution. An easy change using the drop-down of the results we wish to view. An animation shows exactly how this part will deform as it is loaded. Using the bolt as a reference, it's easy to see that there is too much flex in the leveler. Of course, with SolidEdge's synchronous technology, we could easily resize the beam manually to find the best solution, adjusting the overall length and thickness to make the beam stronger. However, rather than manually making changes and rerunning the study each time to check if they'll work, SolidEdge Simulation offers a game-changing tool that takes all of the hard work out of optimizing your designs for simulation. I introduce to you Simulation Optimization. Simulation Optimization is a wizard-based tool that allows users to define objectives of simulation studies and customize how their parts can change in order to converge on the most optimized version. Here, we can set our objective of maximum displacement of 1 millimeter. The next steps include defining limits of the parts, such as stresses that they cannot exceed, and finally, defining which variables that we wish to solve on. This can be a single variable or multiple variables, as here we'll adjust on the length and the thickness of the bracketry to optimize its size. The remainder of the options simply define what is considered solved on the study. Once again, settings optimized by SolidEdge so we can simply keep the defaults. Once we begin the optimization, we see that as it iterates, it's simply taking the values of each subsequent study to make closer approximations to what the most optimized condition will be. Just imagine how long this would take to run each of these studies independently. Of course, running through iterations takes time, but since it's all automated, this time can easily be spent on other tasks, or maybe even just going and getting a cup of coffee, because in the end, SolidEdge is going to provide you with a comprehensive summary of all of the studies and their associated values. The optimization summary is produced in Microsoft Excel, allowing us to easily customize the output if we so desire. We see the study optimized the leveler and provided us with values for the size of the beam, all in a fraction of the time. Once optimized, any results, including animations, can be output or saved off for design reviews, marketing materials, or any other use needed in your design workflows. Of course, generating a report in SolidEdge simulation is a breeze. Automating the creation of screen captures of study results and all of the pertinent information to provide that information to you in whatever format you choose. As you can see, SolidEdge simulation is perfect for design engineers. From making sure your designs are appropriate for their purpose, providing a simple and intuitive method for setting up studies, to a full optimization capability that can solve multiple variables with minimal designer input. SolidEdge simulation truly provides a valuable solution to design engineers. Oh, and rest easy knowing that all of this is done leveraging FEMAP and Nastran, industry-leading simulation technology. SolidEdge, design better.
So in just taking a look at the simulation and optimization, we can see how robust this tool is. But it's one thing to be able to have a simulation. It's quite another to have the report. And you can see with SolidEdge, it creates that report automatically without any issues. One of the biggest challenges that we'll find with many of our customers is when they have gigantic assemblies. How are they able to work with them? Well, if you use SolidEdge, it's not a problem. Let's see.
In this example, we'll look at how SolidEdge handles large assemblies. One of the biggest issues when working on large assemblies is how much time it takes to open and load all of the parts. SolidEdge accommodates for this by giving the user full control of exactly how a large assembly is opened using a variety of different tools. Tools such as Assembly Open As is one way in which users control how they optimize time to open, providing options to define the size of an assembly as well as the state of the parts when loaded. These options are fully customizable and lead to improved performance when working on assemblies of all sizes. Additionally, SolidEdge offers another great usability tool in a top-level assembly filter that filters out all lower-level assemblies and parts, greatly reducing the amount of time necessary to find the top level, especially when being viewed alongside other parts and sub-assemblies. The assembly we're working in today is from a SolidEdge customer, Donito. This cheese factory is one of their large factory layouts containing just under 13,000 parts with over 1,700 sub-assemblies. Altogether, over 700 megabytes of data. The computer we're working with today is a Microsoft Surface Pro 3 tablet device, not a CAD-specific workstation. We've optimized SolidEdge for opening large assemblies, and notice how quickly we're able to get into our assembly and immediately begin work. No matter what system specifications or the size of the assembly that you're working with, SolidEdge provides the tools to utilize computer resources in the most efficient way. Of course, once the assembly is open, another very important aspect is working performance once it's on the screen. SolidEdge offers a great selection tool that allows us to select any parts based on their size in comparison to the rest of the assembly. The Select Parts by Size command is a great way to select small parts, such as nuts and bolts, and hide them all in one action. Once we've hidden the parts that we don't want showing, unloading them from the assembly is a simple process that frees up more system resources for the tasks at hand. Of course, in large assemblies, it's important to be able to work on the data specific to the task. And to help us focus on the shop floor machines, we'll simply use a display configuration, or a preset grouping of parts, to show only those important to us. Notice, many of the components on our machines seem very simple with little detail. That's because these machines have been simplified to cut out unnecessary details that leads to increased performance. Opening assemblies in their simplified state can reduce the opening time of large assemblies by as much as 75%. Of course, as always, SolidEdge gives users full control over which assemblies they want shown simplified and which they want shown in detail. So let's take a look at how simplified assemblies are created. SolidEdge provides users with a full set of modeling tools, so once you begin the simplification process, as many or few details as desired can be included in the resulting simplified assembly. One of the most efficient tools for creating a simplified assembly is the Enclosure command, allowing users to simply click on the parts that make up the boundaries and define a simple shape to represent it. If we need to preserve specific geometry of the assembly, we can easily do so. Here, we need to keep the feet for placement purposes, but rather than simplify each one individually, we'll use the Duplicate Component command to quickly place the simplified versions of the feet all in one action. In addition to the display configurations to turn on and off specific assemblies and parts, SolidEdge also provides zones, a tool that shows all components that lie within a defined area. Zones are also fully customizable, allowing for dynamic size changes to show whatever components you want within the desired working area. In addition to working in zones once an assembly is open, the SolidEdge Open dialog allows users to select a specific zone when opening the assembly for the first time, making sure that only the components necessary for the work task are loaded. Of course, the less parts in a zone, the faster the open time. Another great time saver when working in large assemblies is the intelligence that SolidEdge brings when placing new parts into an assembly. Notice when we bring in the new machine, SolidEdge automatically recognizes that there is a simplified version and uses the simplified geometry to optimize performance. Once fully placed, we can easily turn on the design version of the assembly to see the full details. Our next design task has us making some changes to the packaging equipment on the factory floor. Wouldn't it be great if there was a way to search and isolate all of the parts with specific properties associated to them? Well, luckily for us, SolidEdge has a query tool that allows us to do advanced searches on any property within our assembly files. For this query, we'll simply search on packaging. Using our query quickly provides focus on the parts we need. For our design task, we need to increase the number of packaging machines to 4. SolidEdge offers unique capabilities in assemblies to create exact copies of existing data. Here, we can simply select the machine to copy, click copy, or hold the control key, similar to copy in Microsoft Office products, and then drag it to a new location. When making copies of components, the copies originate from the location of the steering wheel, allowing for precisional placement with keyed-in offset values, or even snapping to key points of other components. Several additional tools also exist in SolidEdge that help to increase performance when working with colleagues in the same assembly. The first is called Limited Update. Limited Update allows users to both limit which parts are loaded when opening, as well as updated when working in a specific area of an assembly. This allows system resources to be directed to the areas of the assembly pertinent to the design task. Additionally, the Component Tracker tool is used to track the assembly and provide a full readout of the statuses of all of the parts, ensuring designers have the most current data when Limited Update is turned on. And of course, once done in 3D, SolidEdge provides great tools to be able to create drawings of the assemblies, with options to bring in individual subassemblies only, or to create drawing views of parts contained only in the display configurations or zones we looked at earlier. No extra work is required to display exactly what is needed. Combine that with SolidEdge's ability to leverage multi-core processors when placing drawing views, and SolidEdge proves why it's the king of drawings. SolidEdge provides you with all the tools you need to work more efficiently in assemblies, whether 13,000 parts or even 2.5 million. SolidEdge, design better.
So that's one of the key things when we're working with large assemblies. The models in other softwares, it'll tend to get glitchy or jumpy, or you're having to have so much detail that you just don't need. Hopefully you're able to see that with SolidEdge, working with large assemblies, no problem. But let's take a look at the last thing. We're going to look at visualization. And this is the ability to take our product and have a concept of it before we even create it. Let's take a look at how this works with SolidEdge.
SolidEdge is a great tool for designing a final product, but did you know it is also a great tool for marketing your product? This marketing could include introducing your product to the public or internally within the company to get buy-in on a new design idea. Using SolidEdge's assembly constraints and motor functionality, you can show management how the internal mechanism operates under the cover. You may also need to show those in manufacturing how the product is assembled and show all the components that make up your new design. Rather than just show a single exploded drawing, it will be much more appealing and generate more excitement to actually see the virtual product explode and animate live on the screen, or share it as a movie saved from the animation environment. SolidEdge gives you simulation capabilities where you can virtually test your designs. Here's a video output from stress analysis testing for strength. This is great for internal marketing, but also may look great on a website, for example, as immediately it's an impressive way to show your products are well designed and validated. Realistic rendering images are always a good tool to use in communicating a new design internally or to the public. The beauty of this is that you can generate realistic looking photo quality images before you ever cut the first piece of material to manufacture your product. SolidEdge provides a one-click export or update to KeyShot's best-in-class rendering. KeyShot makes it very easy to change materials, lighting, and environments by simply dragging and dropping from a huge library of optional materials, colors, lighting schemes, and backgrounds. And best of all, KeyShot is included with SolidEdge. KeyShot enables you to change the environment by tweaking its settings to your liking. KeyShot also offers you the ability to use your own custom image for the background to place your virtual product in a realistic environment. In this case, the razor can be rendered to appear as though it is sitting in a stack of towels. Check out these other awesome images of products designed in SolidEdge and rendered in KeyShot. To gauge a wider audience's opinion, YouTube is a great tool. In SolidEdge, you have the ability to record and upload directly from CAD. The video could be a screen recording with a voiceover talking about product detail, or a completed animation like the one we created previously. SolidEdge offers a perfect solution for sharing designs with its mobile viewing app. The best part is that it's easy to use, robust, requires no CAD license, and like everything tablet, a great user experience, which then gets reflected in your products. Within the app, you can pan, zoom, and rotate the model around to see it from any angle. You can also interrogate the design by hiding the external parts to see inside the assembly. The app also enables you to create screenshots at any time that you could then attach to a message or email or post to social media for fast and easy collaboration. SolidEdge's mobile viewing app is available for both iOS and Android devices. Imagine being able to share your ideas by tablet or by simply using your smartphone. You no longer have to be a CAD expert to share your ideas within your company or with the world. So as you can clearly see, SolidEdge is not only a great tool for designing products for manufacturing, but it is also an awesome tool for reusing that design data for selling and marketing virtual products. SolidEdge, design better.
So pretty neat to see our product completed. And with visualization, that's what we're able to do. What we wanted to do in this little webinar was we wanted to show you some of the other enhancements that you can find within SolidEdge. We started with the basics, that's the synchronous, assemblies, drafting, just done better. And then we finished that up by looking at our visualizations. So the next steps. Well, are you interested in getting a free trial of SolidEdge? How about a guided tour? Well, if that's the case, please feel free to reach out to us and we can make that happen. We're also going to have the third part of this series, what else can SolidEdge do? So keep your eyes open for that. I'd like to take this time to thank everyone for your time and for your attention. Everybody, have a great day.